And welcome to the Office of Undergraduate Research Education series. Today's session is on navigating inevitable uncertainty in life and research. This is a virtual event. It's being recorded, so please mute yourself and turn off your camera to ensure the best experience. And if you have any questions, you can use the chat feature or unmute yourself when invited by the speaker. This is the event evaluation form. We'd love everyone to complete this after the presentation, but we want to remind the Europe, Wilkes, and early exploration scholars, you must complete this in order to get credit for attending today. And the mission of the Office of Undergraduate Research is to facilitate and promote undergraduate, student, faculty, collaborative research, and creative works in all disciplines throughout the U campus. And we would like to acknowledge that this land, which is named for the Ute tribe, is the traditional and ancestral homeland of the Shoshone, Paiute, Goshute, and Ute tribes. The U recognizes and respects the enduring relationship that exists between many indigenous peoples and their traditional homelands. We respect the sovereign relationship between tribes, states, and the federal government, and we affirm the U's commitment to a partnership with Native nations and urban Indian communities through research, education, and community outreach activities. And now I'd like to introduce today's speaker. It's Dr. David Stroop. He's a professor in educational psychology.
Okay, thanks, Shelley. Hi, everybody. I was going to say nice to see you, but you all have your screens off. So it will be nice to see you if you come by and say hi in the College of Education. That's where I live. I also hang out in the College of Science, so I'm the new director for the Center for Science and Mathematics Education. So you can come say hi. That's my email if you ever have questions or want to chat about things. I'm going to talk for a little bit about this idea of sort of navigating, I'm going to call it inevitable uncertainty. And then I'm going to talk for some time, but then I want to open up to your questions and hear from you and chat with you about things. You're going to see some pictures here. So it's going to be a mix of some thoughts that I've talked to other people about around uncertainty. And then I'll tell you a little bit about the research that I do too, which deals a lot with uncertainty. So the way that I thought I would start off is by saying, if you thought you were going to come to this event in February, like here's Shelley and I planned for that to happen. We This was a year ago, over a year ago, that we decided let's do this event in February of 2025. We had to reschedule it because I had some knee surgery, and so I had a partial knee replacement. And so sometimes even when you plan some things, uncertainty arises and you have to sort of navigate it. I'm doing okay now, but that's sort of the story. Um, I think I saw some of the questions that all were asking at the prior to the talk, and some of them are wondering about sort of life choices and career paths and things. And I think my own career is a good example of navigating uncertainty and thinking about how we want to end up being where we are. So my background as an undergraduate, I went to Davidson College. And if you've ever heard of Davidson College, it could be because of college basketball and Steph Curry. He was there after me, but he helps put us on the map. Um, I was a biology major and I was a herpetologist. And if you don't know what that is, it's the study of amphibians and reptiles. So I caught rattlesnakes and I did radio telemetry with rattlesnakes. I caught the largest snapping turtle in North Carolina history. There it is. And I actually got into some PhD programs initially to think about doing rattlesnake research. The more I learned about doing rattlesnake research, the less I wanted to do it, not because I didn't like the snakes. I think they're cool and I still like them, but because I didn't want to do sort of the statistical modeling and things that biologists do. It's interesting and I like knowing about it, but I didn't actually want to do it. I liked being out in the field catching things. So my first point of uncertainty there was, what am I going to do? I decided to get certified to teach science. So I moved to Houston and I taught middle school science, specifically like seventh grade science, for 4 years. And the middle school where I taught had 1,800 kids. There were 60 languages spoken there. It was very large. While I was a teacher, I was part of someone's research project where they were studying mentor teaching, and I got a master's degree. And I remember someone on the project saying, "Have you ever thought about doing a PhD because you seem sort of interested in the research?" I had not. So I moved to the University of Washington and I did a PhD in science education. And I now teach teachers how to teach science and study their learning. And that was another career shift, was moving to that. So if you're wondering what I do exactly, it's this. I think about sort of three things around science education, and I think about how we want students to engage in science that's meaningful to them and not just parroting things that are important to adults, especially teachers. I think that we want to help students enjoy the wonder and awe of doing really interesting science work. If you've never experienced this feeling, I'm sad for you. If you have experienced this feeling, then you kind of know what it's like to be doing really interesting things and not know the answer and find something out that is really fascinating. But I also want students to see how science operates, like currently and historically, and I want them to know that they can become agents of change to disrupt maybe some inequitable practices in science. So all of that leads me to some research about uncertainty and thinking about when we're in positions where especially when we're in positions of power, excuse me, what do we do when uncertain situations arise? So I'll give you an example of research that I've done and an example from a classroom where we can see it. So in science classrooms, teachers have a lot of power and authority, as you know. And here's some examples that we'll talk about. So on one side is Rebecca's class, and they are doing a unit about genetics, and they're asking questions about why identical twins are identical. And in Maria's class, the students wanted to ask a question like, how do we get chihuahuas from wolves? So in Rebecca's class, the one about genetics, they're doing Punnett square problems. And if you've never done a Punnett square problem or you need a quick refresher, a Punnett square is where on either side of the box there's a mother's genes and a father's genes, and inside the boxes are different allele combinations. So they're sort of predictions about what the physical characteristics that the offspring will have. So I'm sitting in the back of the room, and they keep doing problem after problem of these genetics, the Punnett squares, and a kid who's never spoken before raises their hand and says, "When we do Punnett squares, there's always four kids. But what about if there's a fifth kid? Where does the fifth kid go?" So if you know about Punnett squares, that's not what this is. This is one offspring and it's different possibilities. But the student who's never spoken has a really interesting question. And if I'm a teacher or I'm working with new teachers, there's a lot in this question. I have a lot of questions for that student. And so in this moment of uncertainty, the teacher, Rebecca, has to make a choice about how she wants to react. And so, unfortunately, Rebecca's choice was to say, that's not how this works. We need to keep moving to finish the practice problems. In that situation, this is what the teacher decided to do. And I can tell you, because I was in the classroom almost every day, the student that raised their hand never spoke again for the entire year. They really felt like they were shut down. They really felt like their idea didn't matter. And so, even though the teacher might not have been thinking that way when they said that, who knows what the teacher was thinking? We have to move on. We have to move through these standards. The choice that the teacher made in that moment to react as they did had an impact. It had a ripple effect on the student. They never said anything in the class again. So let's contrast that with Maria, who's in this class about how do we get chihuahuas from wolves. And she's asking the students sort of their initial thinking. What do you think? Why is this the case? And there's an arrow pointing to the student named Quentin. And Quentin is kind of a jokester. And he raises his hand and says, what if a wolf mated with a rabbit? And that's how we get chihuahuas. So you can imagine the whole class laughs because it's funny. And he's clearly like trying to get attention. And this is the moment, I actually have a video of this, but here's the moment of Maria. You can see her, the teacher with the pin. And instead of reacting like Rebecca and sort of chastising the student and asking them to move on, Maria says, wait, why did you ask that question? Why do you think that might be important? So there's a couple things that I asked Maria about after this moment. One was she didn't know what to do. So she asked the question in part because she was just trying to think in her mind, okay, I don't know what to do with this, but I'm going to put the moment back on Quentin and have him talk about it. And the second thing was she actually thought maybe he's got an interesting idea, like he's trying to be kind of a jokester now, but he might actually have an interesting idea. So let me try and find out more about his thinking. Quentin, of course, is a little shocked that his joke resonated with the teacher and that she actually has a question for him. In his response, he brings up three really important ideas. So, one is, I think it's because, well, what I really mean is the parents have to be like close together in order to have babies. True. Another thing he brings up is, well, sometimes babies, I guess they get their traits from parents. Like they can't look really dissimilar. True. And even though they might get their traits from parents, the babies will look different than their parents. Also true. So because Maria asked Quentin this question in this moment of great uncertainty, we now have three really interesting ideas in the classroom that weren't there before. And so Maria's choice to actually open up an opportunity for Quentin to speak is really important. So that's kind of the work, that's a lot of the research that I do is looking at these moments around uncertainty in classrooms and thinking about as a teacher or a person in a position of power, what will you do when these moments happen? How will you react? And what will that mean for the students in your class? When I've worked with future science teachers about this question of uncertainty, I'll give you an example in a minute. They're also really scared. I think the most illuminating thing I've ever heard a future science teacher admit is that they were scared of kids, which seems a little strange. But they're not actually scared of kids. What they really mean is, I'm a teacher, I'm standing in front of a class. I don't know what to do. I don't want to look dumb. The students have lots of questions. I want to make sure that I present myself really well. So here's sort of a typical quote from a future teacher. We have them do teaching rehearsals, which I'll get into, but they often feel really scared. They feel uncomfortable and they feel flustered. And I think, regardless of whatever setting you're in, this is specific to future teachers, but whatever you're feeling, whatever field you're in, whatever situation you're in, I think a lot of us don't want to admit that we feel scared or flustered or don't know what to do. So there's two big ideas for today that I want you to, if nothing else, take home these ideas for today. The first one is there's uncertainty. It's just going to happen. And the second one is even though there's uncertainty in whatever we're going to do, you can start thinking about your successes. You can start thinking about evidence that you can provide to other people that you're navigating the uncertainty and that you're doing really well. I think there's four myths about research that if you don't know these or have never heard these, they're important to sort of name because scientists or sociologists or whatever kind of research field that you're in, they want to portray this image about the work that they do, but actually it's not that. So the first one is that research progress is always linear and pre-planned, like we can design it in a particular way. And of course, you want to have a good research design for whatever field you're in, um, but it never unfolds that way. It something always comes up. So nothing ever goes from beginning to end in a way that we imagine. The second big myth is that you're in control of everything. So you can set things up as you hope. You can make sure that you try and get all the variables out of that's possible, but you're at some point you turn control over to the universe and nature and whatever. And when you press go, when you are in a classroom, when you're interviewing people, you can set everything up as best as you hope, but something you're not ever in control of exactly everything. The third myth is that you can predict everything that's going to happen. I know that in schools we try and teach kids this, right? That like you can create the exact hypothesis that you want to test or all the hypotheses that you want to test, and then you'll know exactly what the possibilities are. And great scientists and great researchers will always do the best job that they can to predict what's going to happen, but they can't predict everything. And so uh, something will come up inevitably that you don't quite understand. Excuse me. The fourth one is that you will know how to respond if something veers away from the plan. This is one of the ones that's the hardest to recognize and rehearse, but also know that it's going to happen. So you can think that you will know what to do if a situation arises, but it's always important to know that something is going to happen and you are not going to know what to do. You, in the moment, are going to have to make a choice, maybe a fast choice about how you react to something. If you want a great book, I know you're all busy with things, but if you want a great book and a great way to frame this, there's a sociologist named Andrew Pickering. He's a sociologist of science, and he talks about science, but sort of research largely. Instead of being this wonderfully linear thing that we can always predict, he talks about it as a mangle of practice. And he talks about these moments of research breakthroughs that instead of being framed that we always sort of hear the story of the heroic scientist that finally figures something out, instead of framing those moments as these heroic things, that they're actually a recognition of uncertainty and they're a recognition of when things go wrong and then navigating those moments. So instead of thinking about the scientist or the researcher, whoever being in total control of things, that there's all these different things interacting at the same time, and really great researchers and really great people in their fields will recognize that it's a mangle of messiness, and then they make particular choices about how to proceed that lead to really interesting results. I like to think about all of this. I like baseball, so the World Series is about to happen. So I like to think about all of this through the wisdom of a wonderful baseball player, Yogi Berra, who has a famous quote that says, "When you come to a fork in the road, take it." So I read this as the idea that there's always going to, you can plan the best you want, but there's always going to be things that come up. And what you do, the choices you make have really important consequences for what happens next. I'm going to give you another example of what this looks like sort of in long form in a classroom. And that's a teacher from where I did my graduate school work in Seattle. This is a teacher named Karen, and she's in a class where the students are learning about invasive species and ecology. And so Karen decides to go on a walk through the students' neighborhood, and she sees and notices that English ivy, which is an invasive species, is starting to destroy everything. So she asked some local scientists, "Do you have any data about this? Because I would really love to bring this information to my class. And we just want to study the ivy and see what happens." The two scientists that she contacts, both of them say, "Sorry, we don't have any data for you. There's only two of us. It overwhelms us, so we just try and destroy the ivy." So Karen says to her class, "Sorry, kids, I don't have any data for you. We're going to have to do something else." And I was sitting in the classroom, and a student at the back of the class again raises their hand and says, "Well, even if there's no data, we can still do it. Why can't we collect the data? We can do it ourselves." So you can imagine what's going on through Karen's mind in this moment, right? Like she had told her class in her mind she was moving on. She was going to do something else. And then the students really want to collect the data. They want to be the scientists who learn something. And so Karen has some choices to make. And so she agrees. But because she doesn't have a real plan, she has to work with her students in the moment to figure out what they want to do. The first thing they decide to do is to just take pictures of where the English ivy exists. And so they go around with a camera. They have, I guess they get a few cameras, but that has GIS enabled. So they can get coordinates of where the English ivy exists. So the first task is they start walking around the neighborhood. They start walking around town and they start documenting where the English ivy is. That means Karen has to talk to her principal and say, we're gonna be walking around town. The kids and I, we're gonna be walking around. And she had to have a conversation with the principal and the parents about this is really important. Here's why we're gonna do it. But it is not what she planned to do. They just decided to do it in the class. After they walk around and figure out where the English ivy exists, they decide to come up with a list of hypotheses about why the English Ivy might be so successful. The X-Files thing is there. If you don't know the X-Files because you're too young, it was a TV show that was on a while ago, and there were always aliens. And the X-Files thing is there because a student, as they're building this list of hypotheses, a student suggested that they need to figure out if one hypothesis is stronger than another one. And the reason they need to do that is because they have to figure out if something is more likely to happen than something else. And the student said it could be that aliens came down to planet Earth and that they planted the ivy here to slowly strangle us, but that's probably not the case. So they wanted to come up with ways to test the strength of hypotheses. After they come up with their hypotheses, they have to figure out a way to actually conduct the work. And so I was there, so I helped Karen work with university people, and they donated some equipment, and some scientists actually came into the class to help them set up some experiments to test the hypotheses. Again, none of this is planned, right? We're sort of after every class, we're thinking about what do we want to do tomorrow? What do we want to do the next day? And how can we make some good and important choices about uh, opening up these opportunities for students? As they start to collect the data, the students figure out that they have to come up with ways to see if the evidence they're collecting either supports or refutes some of their hypotheses. So they invented a tool called a red light, green light tool. And it's a little bit hard to see, but on some of these cards, there's a green star. And the green star means that the evidence that they are collecting supports one of the hypotheses. And on some of the cards are little red stars, and those mean that the evidence refutes a hypothesis or doesn't support a hypothesis. And so they've invented this tool. They're writing a lot on the cards, and they sort of figure out over time by weighing the evidence against each other that all the hypotheses are connected, and they start creating these really interesting drawings to and explanations to represent their thinking. None of this again is planned, right? So Karen is sort of inventing all these things as she's going along, but you could imagine that as she's allowing student voice into her class, more and more kids participate, and the kids start doing really well. Kids who have never said anything or never gotten a good grade in science before, they feel like they're really a big part of the unit, and so they start participating in really great ways. I think about it like this. If I were Karen, this is something Karen helped me realize. I think about it in terms of instead of being really afraid of uncertainty, that you have to embrace it. You have to embrace the idea that it's going to happen. And instead of thinking about limiting uncertainty or being scared that it's going to come up, we have to instead think about the idea that we can prepare for different outcomes. We can prepare for different paths. And what we should really focus on is how do we rehearse and react when uncertainty arises. So the reason I have a picture of Roger Federer there, if you know anything about tennis, is if you're returning a tennis serve, you know the serve is coming, but you don't know where it's going to go. And so tennis players spend a lot of their time preparing their body and mind to move and act and react in certain ways based on whatever they see coming off of the other person's racket. They know it's coming, but they don't know what it's going to do. But they know that they can be prepared to hit it. And even if they don't return the serve, and even if the other person gets an ace, there's another chance coming in a minute. So they embrace it. It's part of the game. And I would think for whatever field you're in or whatever work you're doing, uncertainty is part of your game too. So if we embrace, if we acknowledge, if we accept that uncertainty is inherent in the work, whatever work we're doing, instead of being afraid of it, we can start asking questions about how do we provide evidence to other people? How do we show them that the work that we're doing, the work that we're involved in, that we are successful in even when uncertainty arises? So I want to give you an example of that from my own teaching, my own research, where I had to make some decisions about this. As I alluded to, I teach new science teachers how to teach. I used to be at Michigan State University, so these are photos from Michigan State. Um, and I had the pleasure of being able to teach these students for a year. So I had them for fall semester and spring semester, and we gave these future science teachers opportunities to rehearse teaching, right? If we want to be more like Maria and Karen in classrooms, that's not natural. And so we had to give our future science teachers an opportunity to try out that teaching in a place with us. In fact, the blonde hair teacher there, that's the teacher who gave the quote about being really scared about uncertainty. So in the teaching rehearsals that we gave them opportunities to try in fall semester, we really limited the amount of time that the students were teaching. We didn't want to overwhelm them because teaching is a lot. And so we let them try out teaching for like 10 or 15 minutes. In our course evaluations and in our course debrief, the students said to my co-instructor and I, the graduate student and I, that we needed to do a better job as teachers. We weren't allowing them the opportunities that they wanted. So as a teacher, as a professor of these college students, we have some choices to make when we got these teaching evaluations, and we didn't know what to do. So on the first day of the winters or the spring semester, we started to talk with the students about like, you wrote these things in our course evaluations. What do you want? What do you want to do? How can we help you learn better? So they came up with this idea that they called macro teaching. And macro teaching meant that we had to reimagine our class for the spring semester. So instead of the students trying out little bits of teaching and us as the course instructors lecturing to them about what teaching is, we turned the class over to them and we put them in four different groups, and they were all science teachers, right? So those are the groups. We put them in four different groups and we allowed each group to teach our class something about those things in science for 2 weeks. It was really scary as a course instructor because instead of me knowing what the students were going to do, I gave them the keys to the car for 2 weeks, each of these groups, and said, I'm happy to help plan with you. I'm happy to help answer questions and help you write a test or whatever it is that you want to do, but you're going to be in charge of the class for 2 weeks. When we were doing that, we had to think about their learning and our learning. And instead of thinking about their learning as I can predict what they're going to know and I can write a test about it beforehand, I really had to think about their learning as something that emerges in real time. And we had to start documenting how are these future science teachers showing us that they're learning when I don't know what they're going to do next. Here's what we found out that seems really helpful in at least these sort of moments in thinking about the uncertainty of their learning and our learning. The first thing that seemed really helpful was we could talk with them. Even though we didn't know what they were thinking or what they were going to do, we could actually, as the professors of the class, we could talk with them in the moment and ask how things were going and ask how we could help. Another really interesting thing that came up was that the future science teachers, when they were teaching, realized the that they might need some help, and so they could call a timeout. So if they're being the teacher, if they're teaching the other students in their class something and it didn't work really well, or they had questions, they would do like a timeout. They would call a timeout and they would ask for help. And they would say, what should I have done here differently? Or what could I do differently? Often coupled with the timeouts were these ideas of like rewinding time. So they would say, oh, timeout. How could I do this better? We would talk about it as a class. And then they would rewind time and say, let's move 5 minutes into the past and let's start that over again. I could pull them aside. I could notice that they were doing something, or I think that they should do this or try this. And as they're teaching, I could pull one of them aside and say, hey, remember to ask this question, or think about this when you're walking around and talking to the students in our class. We could also have these question and answer sessions. So at the end of class each day, the students that we're teaching would open up the conversation to our whole class, and the students would ask them questions about why they did things as teachers. And they were these very meta moments, but they allowed us all as a class to see the thinking when uncertainty arose and how the future science teachers chose to navigate that uncertainty. And finally, at the end of each of the 2 weeks where all the teachers were teaching, we had a chance to talk with them about the entire unit. And so we would be able to say, You planned this. Here's what happened. What do you think about that? What would you do next? And so we really had these great opportunities to get under the hood of their thinking after 2 weeks. And it really helped the future groups plan. And it really helped them know what they might want to work on in their teaching. These were all opportunities that I didn't plan. I didn't know these would happen, but the TA and I started to recognize them as being really important and interesting. A highlight of that would be in science, we're moving towards this idea of students drawing phenomena and like writing explanations for phenomena. So for one really interesting opportunity that came up for the future science teachers was the earth science team was doing a unit about how there are whale bones in a Chilean desert. And so one group as a joke made something called whale nami, where a giant tsunami lifted whales out of the ocean and plopped them down into the desert. And it was, again, like Quentin's joke about the chihuahuas and wolves. This was sort of a jokey moment, but it became really important for our class and for the teachers to acknowledge that these were real ideas. And we had lots of good conversations about if students in a school did this, how would we react? I still get emails to this day from students saying, this moment of whale nami, because we didn't treat it like a joke, because we treated it like an actual opportunity, that still helps me remember the importance of putting value on students' ideas and making good choices when there's uncertainty. So I think if you're thinking about how do you navigate uncertainty and providing success, or you're thinking about how do I design these opportunities, or when I'm designing things, I think I learned 5 things. So the first one was no matter what kinds of uncertain situations you're in, which will be all of them, it really matters that you've built and grown really strong relationships with the people around you. They can help you, or you can turn to them, or you can figure things out together. But there's always going to be people in whatever setting you're in that can help you. You don't have to do it alone. The second important idea that I've learned is whatever field you're in, whatever you're working on, whatever you're doing, there are people who understand the complexity of the work, and those people can also help make the work accessible to you or to other people. So it is not like any scientist, any researcher, anyone, any teacher, anyone in your life. It's not like they just automatically know how to do this stuff. It's that someone has showed them and they have thought about the different pieces of whatever it is you're doing, and they should be able to help you see those pieces and put them together in a coherent whole. This is I use the word teachers, but fill in the blank for whoever that is. It's important for whatever setting you're in to have these opportunities to practice making decisions, to actually rehearse what will I do if you're in health sciences. I know that they do this in health sciences too, that they try out what will happen if this goes wrong. If you know anything about war games for like military stuff, right? The reason they do these rehearsals is because they know that uncertainty will happen. You can actually practice this. So I would encourage you to do that. The fourth thing is you can have any sort of tools or routines or whatever you want going into a situation, but you have to embrace the idea that you can adapt them. A tool is not just set, or a routine isn't just set. You're going to have to change it. And so you can both think about how you want to do that in the moment, but then you can also do it later on and you can reflect back later about how you want, now that we've adapted it, is this going to be good for every situation? Is it just this situation? How do we want to keep adapting things? And maybe the most important one, and a lot of different fields do this too, is you're in the moment, you have to make decisions, you run through the decisions, and then when it's over, you can, with your colleagues, with your peers, with whoever, you can look back and wonder about what happened. And you can make some decisions about, okay, let's reflect on what we did. Because, in the moment, here's what we were thinking. But now that we can remove ourselves from that moment, how did it go? What do we want to do? How do we want to think about this moving forward? I work with my teachers to do things even like we write things down. Even writing, these are some posters that they designed with their students. It gets down to the level of like, instead of just assuming that we all know what to do or assuming we all can move forward, maybe we even need to just write things down and put them on a wall so that if something comes up that we don't know, we even have words written down in a space and we actually know how to do that. So I have been talking at you for a long time, and I actually would like you to take a minute and ask yourself some questions. And then I would like to open up the conversation. So I would love to hear from you about these questions. And I know that you might have had some other questions for me, but I'm gonna be quiet for a minute. And I want you to take a second and or like a minute and answer some of these questions for yourself. And then I would really appreciate some bravery and some people sharing ideas. And then hopefully that can start a conversation about these ideas. So I'm going to mute myself for a whole minute while you write some of these things down. And then hopefully someone or multiple people will be willing to sort of share some of their thinking about these. So I'm putting a timer on. You got a minute. Go. All right. That was a minute. Is anyone willing to share some of their ideas about a time that they faced uncertainty? How'd you proceed? How did you get help?
Yeah, I can share.
Thanks.
Um, I don't know if my camera's working, but in like a research setting, I face uncertainty all the time, like almost every day in my lab because I'm kind of a new researcher undergraduate. And usually, if I'm uncertain about something, I'll just consult my PI or the PhD student who I work under and get help from them. And of course, they've learned from others too. And so we have a bunch of written protocols that are generated from them and from the internet. And so there's kind of lots of support structures within the lab.
Thank Clay, I really appreciate that. Were you surprised to know that they didn't know what was going on? Like, has there ever been a time where they're like, huh, let me think about that for a minute?
Yeah, I mean, definitely. There's never always just a concrete answer. Sometimes we all have to do a little bit of research and consult the internet or others to figure out what to do.
Super interesting. I really appreciate you sharing, Clay, and it's super interesting to know that like these very smart people with the letters behind their name don't always know what to do. We have to sort of talk about it and figure out. Cameron, I see you got your hand up.
I'm experiencing uncertainty in my research because we're asking perhaps something that's kind of inherent to research. We don't know how to simulate something because we the what the physical parameters of an area are going to be. So we're dealing with the uncertainty of not knowing exactly how to simulate it because we don't know exactly what it's like because it's fairly a fairly new idea pioneered by the lab I'm working in. So the support structure that we have that will hopefully help us get some answers on either how to move forward with it is research that we do without adding that parameter in explicitly. And also, we are in a collection of around 4 labs where we can ask the professors of all of them and get their ideas on how we should proceed with that.
Cameron, can you that thank you for sharing. That's super interesting. Can you give us a little preview or insight into what those conversations are like when because again as I said most people think about research in whatever way like you've already got it figured out you already know the path you're going to take so if you don't mind like what are those conversations like where everyone's sort of scratching their heads and going what do we do.
The question he posed to me was just like, well, what we have to put this in explicitly. Would it work if we just put it in as normal, as if it was just touching the electrode?
Yeah,
And we discussed how no, and we sat in there for around 30 minutes, and we
yeah.
we asked ourselves like, what are we going to do with this? And I gave a few suggestions. He gave a few suggestions. Suggestion got shot down both by him and myself because we just said like, my suggestion was likely the most true way of doing it, but was an unfalsifiable way. We
Mhm.
couldn't, we had no way of knowing what numbers to put in.
Yeah, yeah. So that's interesting for a couple of
So,
reasons, right?
and now we're going to go to the group meetings and ask and pose the question, hey, we have this problem. We don't know exactly what to put in for these areas or how to cordon them off. Here are our thoughts. We open the floor to you.
Even knowing that's such an interesting like uncertainty problem of like even not knowing what the problem is, right? So like even having to figure out, well, this isn't
If
working or we don't
something
know what
is a problem.
yeah, or even if something is a problem, right? So we often think about research as there's a clear problem that we already know what we're trying to solve. And sometimes we don't. Sometimes we don't even know like what the problem is and then how do we approach it. Oh, super interesting. Thanks, Cameron. I appreciate that. Anybody else have any uncertainty things that they want to share? I'm doing a teacher thing, which is wait time, which is I'm just sort of letting the ether exist while we can think about it. I will fill a little bit of Christian, please, if you want to jump in, go for it.
I was just gonna say I've seen some uncertainty in because a lot of my work with my PI involves designing new formalizations for because I do artificial intelligence research,
Yeah,
specifically interpretability, and so we're trying to figure out ways to formalize the behavior and the internal thought processes of
yeah,
these models, but it's a very new field. And so
yep,
there's a lot of uncertainty in the even the kind of math we'll need to use to formalize it, the kind of
yeah,
experiments to run. We usually approach it by just talking about it.
yeah,
We'll both talk, we'll both share our experience, and me and one of the other grad students will also talk, and then we'll all leave, go read up on the literature in each of our respective ideas, and then come back and try to create a falsifiable or falsify everyone else's ideas until we've got, and we just iterate on that, and that helps. But it is a very uncertain field because it's a field that doesn't really, it's a new field, which is fun, but
yeah.
interesting.
Yeah, thank you, Christian, for sharing. AI is such a fascinating space, and I have a question for you. It's a fascinating, it's new, and no one knows what's. I always appreciate hearing from the companies that are now sort of admitting that they don't know what it's doing or why it's doing what it's doing. Have you ever encountered that, Christian? Like you're building something for the AI, and has it ever hallucinated on you, or has it ever
Uh,
given you some code, and you're like, what is going on?
Yeah, it hallucinates all the time. So my research is less so using AI and more so studying. I'm studying mechanistic interpretability. So I'm studying what the internal thought processes
Yeah,
are
yeah,
that cause it to do things like hallucinate and cause
yep,
it to remember specific facts and things like that. And yeah, we have no clue what's going on.
yeah,
Um,
yeah,
we that's my work. Currently, we found out a bunch of really interesting things that I won't go into the technical details on,
yeah.
but we have no, it's all black boxes all the way down. The companies don't know how it works. They just know if they put
Yeah.
money into it, they get money out of it.
Well, they hope they get money out of it, right? Yeah, if you ever thanks, Christian, that's so good. If you ever need to feel better about yourself as a person, you can read some news stories about all the times the AI hallucinates, and then people there's like attorneys who are using it to write court briefs so that and it makes up legal cases. One of my favorites is the Air Canada story where they had an AI chatbot who was helping people with reservations, and it someone had a bereavement flight, so someone in their family died, and they were working with a chatbot to fly somewhere in Canada, and the chatbot gave them a really great rate. In fact, it was so great that the human beings, when they saw that rate, thought it was wrong. And then the person sued the Air Canada, and the Canadian Supreme Court sided with the person and said, "Well, you put the chatbot in charge of giving it rates, and it gave it a rate, so now they don't use the chatbot anymore." See, sometimes you have to make hard choices around uncertainty. I know we're getting sort of close to time, so Shelly, I'm gonna turn it back over to you. But if you have any questions or you want to talk more about any of the ideas, please let me know. I really enjoy. It's always a little bit of a strange space to talk to black screens, but I live in the College of Ed and in the College of Science, and we'll have some events too. So it'd be nice to see you in person. But Shelly, I'm going to turn it back over to you. I'll go to your next slide.
Well, I have some questions from the
Oh yeah. Oh
registrants.
right. That's right. Well, I'll put this up, but let's do some questions for a few minutes too.
Okay, one registrant asked, how do you distinguish between productive uncertainty and signs that a research path may be fundamentally flawed?
Oh man, that's such a good question. Um, there are people who study this, and I think a lot of the people who were willing to share their ideas, again, thanks. I think the thread that you all shared was that there no one person has to or gets to decide whether something is unproductive or not. It's a very social process. And so whether it's in your lab space that you personally are doing and you sort of negotiate what you're doing and when and how and why you're doing it, or the social space could be the field, right? So I am also the one of the co-editors of a journal in my world. It's called Science Education. And sometimes the field will tell scholars that their work is a little bit on the wrong track, or we don't want to see this kind of work anymore because they'll reject papers in peer review, or they'll have, you know, some really hard comments for the authors of the work to think about. So I never think that it's one person making the decision. I think it's a really social process.
I have another question from a registrant. Would it be better to put all your effort in minimizing uncertainty or into managing the uncertainty when it occurs?
Oh, I don't think about those as dichotomous. I think you should try and do both. So I think you should always try and mitigate anytime you can try and mitigate uncertainty, right? Is probably good. You want whatever it is you're working on to go as smoothly as possible. And you have to embrace the idea that something will be different than you expect. And so regardless of how well you plan and regardless of what you do, you have to think about what you'll do given the uncertainty. I actually think personally that's really interesting research, especially when you try and write it for publication for other people. I think it's really interesting research to be able to tell people this is how we tried to mitigate the uncertainty. Here's all the things we did. We tried to control for this and this. We tried to make sure this didn't happen. We tried to make sure this did happen. And here's that. Here's all the things we tried to do. And even still, here's what happened, and here's what it makes us think about. I think that's really interesting research because the more that people can see your reasoning and understand your reasoning behind your design of your work, the research, the more that they can try and replicate it, right? Which is really important. But then they can also see, okay, even though they designed it really well in this way, they tried to make sure that everything was going to go smoothly. When it didn't go smoothly, or when something changed, or when something surprising happened, here's what they thought about. This helps me as a researcher. This helps us as a field because now we can get an insight into what the people were thinking. So I think it's both of those things at the same time.
What are tips for not getting discouraged or stressed out when research is not going the way you expect?
I mean, sometimes you're going to get discouraged and stressed out. Sometimes I do, and I think it's okay. I mean, you never want to be discouraged or stressed out, but I think it's part of it. I think there's going to be times where it feels like you've hit a wall and you don't know what to do, or you're not quite sure what's going to happen. I always tell my graduate students there's like two big things. So one is find the community of people, whether it's in our lab, whether it's your peers, whether it's colleagues, and talk about this with other people. I think most people get really discouraged when somehow they feel like they bear their entire responsibility for things going well. And so it's never you by yourself. There's always people that can help you, PI, grad students, postdoc, whatever the people around you are. It's never your own responsibility, especially as an undergraduate, to make sure that everything is going well. The second thing is I it's sometimes really easy to get caught up in the work that you're doing and feel like you've got to figure this out now. And if I ever start to feel that way, I do something else. I go run now that I have my new knee. I like to play Ultimate Frisbee. I do that. I walk outside. I do something else because sometimes your brain just gets stuck in a rut about you're only seeing it from a particular way. Why isn't this working? You like try and brute force it through. And sometimes you just have to step back and just give it a minute and go do something else for a little while. And you can always, the work will be there. You can always come back to the work. And it's important to sort of take a break and give your brain a break and then come back and you might see it differently. That usually happens to me.
Okay, I will ask one last question.
All right.
How can you take pride in your research and feel motivated when the research is different than you envisioned?
I think that's always fun. I mean, I have a couple of thoughts about that. So what is, to me, that's the most fun is when when you embrace the idea that it's going to be not what you expect. And then think about when you've heard a speaker come to the U or something, or like you've gone to a conference. Those are always the most interesting and compelling stories is I thought this was going to happen and it was a totally different thing and this happened instead and isn't that cool? That's always the story we like. That's sort of a human thing. But I also think you can celebrate, you have to celebrate like the fun small wins that you get. So, whatever a celebration means to you, but like celebrate when something goes really well that you didn't know was going to happen, or you make a choice to do something different in your research and it leads to something fun. Those are the ways that you celebrate those wins. And I think it's a wonderful idea just to be enthusiastic about when things happen and you don't expect them, but you make a really interesting choice and it makes something cool happen. I think you have to celebrate.
Well, thank you, Dr. Stroop. This has been very informative. I want to remind everyone about the event evaluation. I'll put it in the chat one more time. We'd love everyone to complete it, but we want to remind the Europe, Wilkes, and early exploration scholars that you must fill it out in order to receive credit for attending today. And I just want to remind everybody, the Office of Undergraduate Research, we're in the SIL Center, which is just across the parking lot from the Union. Our website is our.utah.edu, and you can email us at our@utah.edu. And thank you again, Dr. Stroop. It was great that we got to do this after originally planning it for last February.
We navigated the uncertainty.